All right, this session covers the use of a fairly new material to the work we do. It's high density polyethylene, very, very thin polyethylene. It's very, very pure in terms of its manufacture. It can be very, very thin and still strong. And it has several good applications, but one of the main ones is because of its purity, it tends to be a good contact material. So that's good. That helps us right off the bat. But also with it, you can make different things. And here we're going to do two methods that utilize the high density polyethylene bag and a heat sealer. Strictly speaking, you don't have to use a heat sealer, but for our purposes, it's a really good thing. It would be nicer if we had a full-size one that's about yay big with a foot switch that you can dial in all the settings. They are pretty expensive though, and at this point we're not doing that. We don't need the volume. So what we're heat sealing inside of here are two different things. We're going to heat seal basically what they call loose fill. And then we're also going to do, after that, we're going to do some polyester batting. Both of these will function as basically a very simple form of isolation. It's doing something to keep something else from hitting, anything damaging. And loose fill in particular has a really bad reputation that's well deserved. It goes everywhere, as we all know. It sticks to everything. It's staticky. It attracts dirt. It gets lost. So if people try to repack with it, they always end up with less packing than they start with. So it's just not approved of. However, bagging it has a tradition that goes back many, many years. Unfortunately, even back then, they used heavier bags, and so it didn't really work as well. So here we'll start out with one option. I talked about the heat sealer. There is another option in a pinch that you can do, which is if you don't have a heat sealer, you can actually get these very thin bags that are especially like an office waste liner. And you don't want to put tape on it. If this is going to be around an object, you don't want tape, so you don't have too many options. Also, it's not good because the bottom of this doesn't lie flat. It comes to a point, so that makes it kind of funky. In a pinch, if you're a little less professional than we like to be, you can kind of tie it up and try and use those, but you know what? It'll still leak around there. It's still not a great thing. But it is better than having them loose. The reason we're going to do this and use them is they're inexpensive. Both components, the high density polyethylene and the peanuts, are very inexpensive. But this is, the reason you use loose fill is because it's loose and it conforms. So this is keeping the ability for it to conform without them actually being totally loose. And so that's why when you go to fill up out of your hopper peanuts, you're going to make a variety of different quantities in the bags. So you can have, for larger areas, you can have a fuller bag. And then for smaller areas, which actually should comprise the majority of it, you should have it very loose, no more than that, and sometimes less than that. So when it spreads out, it can get very thin into little areas of the packing that will fit the shape of the object and won't allow the object to shift the way they would through loose peanuts. So basically, the heat sealer works thusly. This is a heavy-duty heat sealer that's reduced with a rheostat, and to get to just the temperature that it's going to basically fuse these two layers together very rapidly. So this takes very little time. Literally just a quick clip like this melts all the way through both of them and provides a good seal. Then on top of that, what we need to do is puncture it, which you can do with a number of different things, an awl or whatever. As long as it's sort of round, it's fine. Because we need the air to be able to flow out from around it. Just a number of those, doesn't matter where. And then both to test our seam and also to get a realistic perspective on it, you want to kind of squeeze it out. That's good to put your holes up near the top. And that'll give you an idea of the volume that you're going to get out of a bag. That's a fairly large one, actually. And so when we do this, what we discover is that normally you'd use between 2 and 3, probably better to be 3 of these bags per cubic foot. It's about like that. So in other words, and they take typically about 30 seconds to make with a totally brand new person doing it. And so if you have a dish pack, full-size box, that's going to be about 5 cubic feet. That's going to be about 14, 15 of these bags. So we're looking at something like $7 worth of material. So basically, you have your object, you kind of seeing what you need. You're making your space. Often you can even start with a compartment. Typically, in many cases, we do use foam, but we'll just use it as a lining on the bottom. It seems to be an industry standard. So if you need a flat bottom, say in this case it has a base, you can go down to that. If it's a rounded object, you wouldn't want to do that. You'd want to make a little nest, just like that. Basically, I'm spending a lot more time talking than I need to pack it. I can basically go right in here, move this around my object, go in and wherever I need to fill the space. As you can see, the sort of it'll crumple down however I want to use it. And of course, we'll come in here, and that fits in there. And hopefully, we'll have some left over, unless we're packing insanely small things. But basically, that's how long it takes to pack. Just fold the tops over, tape it, and away you go. All right. The second application we have for using the heat sealer and the polyethylene, by the way, I didn't mention before, the bag is, this is a 1 mil bag, which is a little thicker than is ideal for this. You really like something thinner, like what we use. That's the painter's plastic kind of thickness, which is about 0.35. But this is a little more durable, and it still conforms well in ways that we want it to. Still, it allows the material underneath to do what it's supposed to do. In the case of peanuts, we want it to kind of fit in and mold around it. It's almost like clay. In the case of the next thing, which is batting, what we want is for it to be able to conform to irregularities in the surface of something. And if you have something too stiff over it, if you put regular 4 mil poly that we wrap paintings in over it, it's just like a stiff, flat thing. It might as well be foam of any sort. It doesn't have the ability to conform, whereas this will allow it to do so to a much higher degree. Anybody who's worked with batting probably doesn't like the idea of this right off the bat, and I don't blame you, because if you go to cut it, normally it has a tendency to want to put up a fight and tear more. So a lot of people use scissors, and then you get these raggedy whatever. And you also, if you're cutting with kind of normal methods, you're cutting one sheet at a time. And that's typically not what we're going to do. We're not into making custom things, we're into systems. Usually what you would do is you would have the bags that you use conform with something else you have established, like a box size that you constantly use. It could be twice as long so it folds around. It could be the exact footprint of it. In this case, since this is a very limited use, I just bought a convenient sized bag that would be good for both this application and for the peanuts. So that's what's determining this. So when you go to cut it, the thing that really works the best is a straight edge, especially if you want to cut multiple layers. And usually when we're doing any cutting, or anything we're making, if we can get multiple cuts per stroke, cut multiple pieces at the same time by having it stacked up, that's what we want to do. So one thing to facilitate that, and especially to have them be consistent, now if I have a straight edge to cut this, I can do it. The way I do it is if this is pressed down firmly enough, down to the surface, it'll hold it tight and it will cut, especially if you take the angle of the knife and keep it very, very low to where it's a shearing cut. If you get like that, it'll start tearing on you, which you don't want. You want to kind of be pushing down and pulling back at the same time. And then you can get a stack of these, literally a stack of these, several thick. Which is groovy, but you don't want to have to do 4 cuts that way. And this is kind of a movable material, so you don't want to be doing doing that repetitively, typically you want to then have a template. And there are different things. You can use masonite, but then you might end up getting masonite shavings. Obviously, if you had metal, that'd be groovy, but hey, I don't see us having metal. One option is scrap Plex. You can also see what you're doing, so if something's a little, you know, is cutting underneath and you're not going to have a full cut, then you know. So it's the same thing here. If you're pushing down on the angle that you want, on that side, that compresses it enough that you'll get clean cuts. And obviously, if you have a big old stack of this, here I wasn't pushing down on that part very well, but that way you can get a series of these that'll all be consistent. Polyethylene takes just getting used to because it is so light. The trick here is just to let gravity help us out a little bit by holding it up and holding the batting by one corner. Getting it right up in there, and that'll allow us to get the rest of it to go in and be flat, because that's the whole idea. You can have a nice little flat pillow like this. Now it doesn't have to fill up the whole bag. You can do different ways. If you had a real good sealer, you could make different shapes much more easily. But we're not going to do that. We're just going to seal this off so no fuzzy stuff can come out. If it did come out, it wouldn't be horrible. The polyester batting is basically passes Otti tests. It's considered safe, so you could use this system for object and storage, and it's just like the other system. You can just come down here, and it's important to get the temperature right. If you get it too hot, it will basically goop right out on you. You'll see it melt. If you get it too, if you don't get it hot enough, it'll look like it's sealing, but then it'll pop. It can pop out later. All right, here we are at the application that caused these pillows to be made, which luckily, as you can see, doesn't take much time at all. What we have here is architectural models. There's a series of models that include salt crystals that have been formed on the outside of them that project, obviously, and have a delicate surface. And that's what we want to conform around. And so our foam doesn't, you know, push unevenly on the projections. And they're too small to be able to go in between. So we need something that conforms to that shape. We're using one of our boxes here that is a hybrid box. It's similar to the cardboard plywood combination. Only in this case it's Coroplast, which we recently got good pricing on, which is really, really good because it gives us a lot of other options. Here we have a situation where the crystals project out from the sides, especially the sides and the bottom edge. So we have a little, basically a pillow underneath, and then we have a pillow above. It goes into this void, and because the crystals are less prevalent and less important on the inside, we've got blocks that have been fitted to individual areas that are the flattest, where there are the fewest crystals that they can affect, and the smallest crystals. So basically, that's the application for this one. The thing I should say about the pillows is that they were pre-made for this. We sent this box out. The lender didn't really want us to spend the time on site to do it. So luckily, since we have these pillows, this piece and other pieces, they were able to put them on a tray and stretch them using stretch wrap, which of course also conforms very nicely down on that as a way to transport. So that might be a more common use of this than for crating.